Good morning, Alex, Frank, William, distinguished guests, ladies and gentlemen. First of all, I could not think of a more timely juncture to organize today's conference with such an important, to me, very, very important theme of engineering the future. Now, which provides a platform to showcase the diversity and significance of engineers' contributions to our cities around the world. Now, my department, Civil Engineering and Development Department in Hong Kong, has been endeavoring to take forward infrastructure construction and land supply projects for supporting the social and economic and all the sustainable growth of Hong Kong. Now, with the vision of building a world-class, sustainable and resilient city for living, playing, and working in Hong Kong, I'm pleased to share some of our experiences. Now, Hong Kong is a city that features the fusion of tradition and innovation. West meets East, a place where I believe some of you may have visited. Now, over the past few decades, now the Hong Kong government has been implementing a substantial number of public works projects with a view to improving people's quality of living, enhancing the city's long-term competitiveness, and promoting the economic development of Hong Kong. Now, with a huge volume of infrastructure works in the pipeline, particularly the development of the Loving Metropolis, which I will briefly talk about in a minute, the annual capital works expenditure in Hong Kong will increase from an average of around 9 billion British pound to more than 12 billion British pounds in the next 5 years. Now, under the overall national development, our national governments indicated clear support for Hong Kong's development into an international innovation and technology center. Now, under a new industry pattern of South-North dual engine, which is finance at the south and I&T at the north, the Loving Metropolis will be developed into a new international I&T city, integrating quality life, industry development, culture and leisure, and green living. Now, my department has been tasked with the development of the Loving Metropolis. Now, let me show you a short video about this development.
The Northern Metropolis is a large-scale development project in progress in Hong Kong, building a new metropolitan area in the northern part of the city as a new economic engine, a livable community, and a quality platform for regional cooperation. Covering Yuen Long and North districts, the Northern Metropolis has an area of 30,000 hectares, about 1/3 of Hong Kong's total, capable of accommodating 2.5 million population on completion. The Northern Metropolis comprises 4 major zones. The Hung Shui Kiu vicinity will become a professional services and logistics hub. San Tin and the Loop will focus on innovation and technology. Boundary commercial activities and industries will develop in new territories north. Robin's Nest and Sha Tau Kok will be a base for recreation and eco-tourism. Construction for new development areas are progressing at full steam. We adopt multiple development approaches to leverage market forces and expedite the development of the area. The project is gradually bearing fruits. The coming years will see more residential developments completed, industrial land ready, and transport infrastructures commissioned. Blending urbanization with nature, an ideal place for work and life. a new engine of Hong Kong's development, the Northern Metropolis.
So we aspire to create vibrant, livable, and sustainable communities in these major development projects for our next generations. Now, in order to achieve our vision and goal, we have adopted a set of smart, green, and resilient strategies in the development of the Northern Metropolis, including sustainable planning and urban design, integrated SGR infrastructure system, and smart and green mobility. Now, let me briefly introduce some of the sustainable planning and urban design. Now, first of all, we will adopt a 15-minute neighborhood concept for the planning of the living communities. Now, each community will have a green mass transit station at the center, with other public transport stations, daily shopping and dining facilities, community facilities, open spaces, etc., within 15 minutes reach, either by walking or cycling. In order to provide a healthy and a comfortable environment, stepped building heights will be planned, and we will align the open space and breezeways with the prevailing wind directions. While we also encourage buildings to adopt sky-rise greening, including rooftop greening, vertical greening, sky gardens, etc., to reduce heat island effect and lower energy consumption and carbon footprint of the buildings. We will provide a whole array of integrated smart, green, and resilient infrastructure system, including smart city design concept, comprising sustainable urban drainage system, such as porous pavements, bioswales, retention tanks, etc. We will put in place a comprehensive network of renewable energy facilities, in particular solar energy panels, to harvest clean energy to support the city operation. We will also provide a district cooling system which has higher energy efficiencies and lower carbon footprint to support the development, particularly the I&T industry. We will construct food waste and sewage sludge co-digestion facilities that they form part of the municipal infrastructure of our community for handling waste in an environmentally friendly manner. Extensive common utility tunnels will be constructed to house various underground utilities. Now, this common utility tunnel will effectively avoid public disturbance and the associated energy consumption and waste generation arising from road excavation for laying and maintenance of underground utilities. The new development areas will adopt resilient designs capable of meeting the challenges of climate change and extreme weather. For smart and green mobility, we have planned comprehensive pedestrian and cycle track networks to allow residents to travel by healthy modes, such as walking or cycling. Extensive supporting facilities for electric and other new energy vehicles will also be built in order to actively promote the development and use of new energy vehicles to improve roadside air quality and reduce green gas emissions. Last but not least, new generation transport interchange hubs will be provided at strategic locations. Now, they will become an important link between transport and development of neighboring areas by providing diversified one-stop transport facilities and ancillary facilities to enhance passenger travel experience, thereby improving transport services. Now, just now I have talked about our smart, green, and resilient strategies for our Northern Metropolis. Right? Actually, over the years, my department has been working closely with universities and industry practitioners in developing and applying novel materials and technologies in our projects. Our aim is achieving better sustainable, green, and resilient development. Now, let me share with you some examples. Now, the first one is the use of what we call the S690 high-strength steel in the construction of a steel bridge, what we call the Cross Bay Link in Hong Kong. Now, other than its functional purposes of coping with the anticipated traffic demand in the district, we put forth the initiative of green commuting in the design of the project, combining functions of a road, cycle track, and footpath on the Marine Viaduct. Now, we extend its green commuting by connecting it to the coastal cycle track of the existing bay, forming a coastal bicycle loop with a total length of about 5 kilometers. Now, facing the demanding technical requirements, especially on the long span length of the bridge, CEDD, my department, has adopted advanced construction materials in the construction of the Cross Bay Link. Now, we have collaborated with the Hong Kong's Polytechnic University for using grade S690 high-strength steel, the first time ever in Hong Kong, to fabricate the double-arch steel bridge. The demerit of using this high-strength structural steel is a saving of 4,400 tons of steel, as compared with using conventional grade S355 steel, now resulting in cost saving and also cut carbon footprint due to reduction of steel usage. Now, as a result, the weight of the bridge was greatly reduced, therefore reducing the scale of the substructure of the steel bridge, as well as allowing double-arch main segment to be prefabricated off-site, transported, and erected by using what we call the float-over construction method, as shown in the video here, all in one go. Now, the Cross Bay Link now becomes Hong Kong's major attraction, not just on its appearance, but how we have promoted green commuting to our people. We actually do not stop after the success of the S690. Now, we have taken the lead in developing the standard and design guidelines for S960 ultra-high steel, strength steel, and use this material in the constructions of 3 pedestrian footbridges under the Loving Metropolis. Now, this is the first time in the world to use S960 steel in the construction of footbridge. Now, the video on the left-hand side shows the lifting of the footbridge that we completed in July this year. Now, having a much higher tensile strength, the ultra-high strength steel significantly reduced the weight of the circular deck from a 2,500 tons RCP stress structure under the original design to some 280 tons only, a reduction of over 90% in weight, thus reducing the number of foundation piles and therefore leading to a decrease of about 30% in the overall construction cost. It also helps reduce carbon emission, of course, for the works. In addition, components made of S960 steel were prefabricated in factories, which not only significantly reduced the number of on-site procedures, but also enhanced site safety, improved construction efficiencies, and shortened the overall construction time. Now, another novel construction technology adopted in a bridge construction is the horizontal bridge rotation method used in another project of the Loving Metropolis. Now, the project involved the construction of an approximately 4-kilometer long dual-two-lane road link, comprising viaducts, at-grade roads, and underpass sections. Now, we have introduced the bridge rotation technology, the first of its kind in Hong Kong, in the erection of 2 bridge sections over an existing railway line. Now here it shows you how the works were done. Now the innovation rotation of 2 bridge sections, with the longest one of up to 138 meter long and 7,000 tons in weight, was successfully completed within 3 hours in the midnight. Now compared with the traditional method, this innovative method significantly reduced the number of nighttime operations above the railway from over 100 nights to just 2 nights. Now, our success was not only on the time and cost saving, but also significantly reduced the risk of construction above the railway. Another example of novel construction method that was adopted in our tunneling works is on the use of a rectangular TBM in a construction project in our urban area. Now, this project involved the construction of a 140-meter subway, a long subway which is located in an area congested with many existing underground utilities, viaduct foundations, and large water-carrying conduits, thus imposing great technical challenges on the construction works. Now, to overcome the challenges, we brought in Hong Kong's first RTBM, the rectangular TBM. Now, the rectangular TBM cutter head was equipped with 1 main and 4 auxiliary cutter discs. Now, tunnel excavation was integrated with the sampling of precast tunnel segments, 92 pieces in total. The segments constituted the permanent structure and support the adjacent ground during tunneling construction. Now, it took only 6 months to break through. This tunneling machine not only minimized construction risks and environmental impacts, but also enhanced works quality and productivity. Other than our TBM, the rectangular TBM, we use U-shaped TBM, again, the first of its kind in Hong Kong. Now, under another project of the Northern Metropolis, a box culvert needs to be built and existing engineered channeled alongside an existing heavily trafficked road. If conventional ELS is adopted, compressed multi-stage temperature traffic arrangement has to be implemented in order to spare sufficient space for the box culvert construction. As a result, the production rate will be less than 1 meter per day. Now, UTBM is thus proposed. That the UTBM incorporates cutting-edge technologies for module manufacturing and the pre-assembly of an open-cut tunneling machine. Now, the video on the left shows how the UTBM operates. Now, the U-shaped shield structures operates at channel bed level, allowing space for an open trench excavation in front and precast units installations at the rear. Now, UTBM requires smaller working space, thus the existing two-lane traffic could be maintained throughout the construction period. Now, compared with the conventional ERS methods, the UTBM can advance at a remarkable rate of 6 meters per day. It significantly expedites the completion of the box culvert by 400 days. When we plan our infrastructure, we take nature and conservation in our hearts as well. Now, one example is the construction of eco-shorelines in a reclamation project that we completed recently. We have introduced a total of approximately 3.8 kilometer living shoreline, comprising the rocky shoreline, mangrove eco-shoreline, and vertical eco-shoreline that create different topologies for access to seafront and also to mimic the naturally occurring coastal landforms for marine organisms, thus enhancing biodiversity and creating a vibrant water-friendly culture along the promenades. Other than the eco-shoreline, my department is also piloting the Urban Mini-Forest Initiative in the Northern Metropolis with a view to enhancing the biodiversity of the built environment. Apart from the SGR strategies that I've just mentioned in the previous slides, we will focus on one more important initiative, which is to pursue nature-based solutions in the development of the Northern Metropolis as an important means to improve climate resilience and support biodiversity. Now, in order to implement this initiative in a more structured and systematic way, we are developing a nature-based solution guidebook, which aims to facilitate the adoption of the nature-based solution in our projects and ensure nature-based solution is designed in a consistent manner. We have reviewed relevant literature and publications to understand global experience and practices and identified what we can incorporate and improve to better suit the local context in Hong Kong. So because of time constraint, I'm sorry that I can only share a few of our initiatives and work with you today. But all I can say is that my department has been embracing innovation, and not just on advanced construction materials and technologies, but also with equal focus on nature conservation. Again, in our continued efforts to strive for excellences in building Hong Kong into a world-class, sustainable, and resilient city for living, working, and playing. Thank you very much.